Welcome back to Arxflix. Today, we're diving into a groundbreaking paper titled ObjectDrop, Bootstrapping Counterfactuals for Photorealistic Object Removal and Insertion. This research tackles the challenge of generating photorealistic images with physically plausible object edits, like removing or inserting objects while accurately modeling their effects on the scene, such as shadows and reflections. This figure showcases the power of ObjectDrop, demonstrating its ability to remove and insert objects while accurately capturing their impact on the scene. Let's explore the key insights of this paper. Traditional image editing methods often struggle to achieve both visual appeal and physical realism. While diffusion models have significantly improved image quality, they frequently fail to model the effects of objects on their surroundings. This paper delves into the limitations of self-supervised approaches for object editing, highlighting the need for a more grounded approach. The authors propose a novel solution centered around a counterfactual dataset. This dataset consists of image pairs capturing a scene before and after an object is removed, while minimizing other changes. This figure illustrates the core concept of ObjectDrop. By training a diffusion model on this carefully curated counterfactual dataset, the model learns to accurately remove objects and their effects on the scene. The counterfactual dataset proves highly effective for object removal, even for large or inaccessible objects not seen during training. This figure demonstrates the impressive generalization capabilities of ObjectDrop, successfully removing objects in out-of-distribution scenarios. However, the authors discovered that the counterfactual dataset, while effective for removal, is insufficient for training object insertion. This task requires a much larger dataset to accurately synthesize shadows and reflections. To address this, they introduce a clever bootstrapping technique. They leverage the trained object removal model to create a vast synthetic dataset by removing objects from a large unlabeled image dataset. This synthetic dataset, combined with fine-tuning on the original counterfactual dataset, enables the model to learn object insertion with high fidelity. ObjectDrop achieves remarkable results in both object removal and insertion, surpassing state-of-the-art methods like EmuEdit, AnyDoor, and Paint by Example. This figure compares ObjectDrop's object removal performance to a baseline in painting model, highlighting its superior ability to remove objects and their effects. This figure showcases ObjectDrop's advantage over general editing methods like EmuEdit and MG, demonstrating its ability to produce more realistic and accurate results. This figure compares ObjectDrop's object insertion performance to baselines like Paint by Example and AnyDoor, highlighting its superior ability to preserve object identity and generate realistic shadows and reflections. ObjectDrop represents a significant advancement in photorealistic image editing. By leveraging counterfactual supervision and a clever bootstrapping technique, it overcomes the limitations of self-supervised approaches, achieving unprecedented results in object removal and insertion. This research paves the way for a new era of image editing, where objects can be seamlessly manipulated while preserving the physical realism of the scene. Thanks for watching Arxflix. Don't forget to like, subscribe, and share this video with your fellow researchers. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.